My name is Harry Hu, and I'm in Physics 2211, and this is my Lab 1 Constant Velocity Lab Report. For the lab instructions, we were asked to observe the motion of an object, in our case a ball, moving at a constant speed without changing directions. We're supposed to take a video of the ball, use apps like Tracker and GlowScript to gain observations from it, and then to apply our knowledge to observing what we just saw in the experiment. Some basic and introduction concepts would be Newton's first law, which in turn means a motion in motion tends to stay in motion, and an object at rest will stay at rest if there is a balanced force. Newton's second law is basically force equals mass times acceleration, and applies the momentum formula. Listed below those laws are three different formulas that we will use, and the side note is that our velocity is constant, so our net force is 0. And here is our tracker experiment. As you can see, I will roll the ball to the left of my desk. A question is, what if I flip the axis in the tracker? First, the speed of the ball will still be the same, since speed is based off of magnitude and not direction. However, velocity would be different considering it is a vector, and would account for that. Since my graph is downward sloping, if I switch my axis, my graph would become upward sloping. And instead of moving to the left, my graph would show that my ball is moving to the right. Here are some of my calculations. My average velocity is just the initial velocity, which would be my change of x over change in time, as you can see, which is 1.296 meters per second. My initial position is just the zero vector since it was at the start. My ball mass is 0.163 kilograms. My final observed time is 2.666667, and I started at 2.3. My net force is 0. Because my net force is 0, my final velocity will equal my average velocity, thus my initial velocity. Here's my GlowScript code. In my GlowScript code, I made minor changes to the time, the velocity vector, and the position vector. Here is my GlowScript simulation. The computational model and observed model have similarities and differences. Both models have an identical slope until the end. They are downward sloping and have the same constants. The difference is that the computational model does not account for other forces like frictional force. There could be human error in the tracking device that I have made, and the ball mass I might have made a mistake in its calculations. What does this mean? The net force is 0 because the ball is at constant velocity, meaning there is no external force acting upon it. I cannot say how many other forces acting on it because it is impossible to account for all of them. An object in motion will stay in motion, seen from our ball, and the force is applied by my hand and only going in the x direction. To summarize, we analyzed the motion of a ball at constant speed using Tracker and GlowScript. We created a model to represent the ball's direction and movement. We applied our knowledge of Newton's laws to the experiment, and we applied our knowledge of the kinematic equations to the experiment in helping to solve our problems. Thank you.